The Albertine Rift, forged by fire and geological violence, generated mutants and evolutionary mysteries. It pushed up Africa's tallest mountain range, where unique creatures evolved to survive in an alien environment. In toxic swamps below are air-breathing fish and prehistoric-looking birds. The rift created the mighty Congo River, dividing our closest relatives into societies of love and war. These powerful forces shape all life in the Albertine Rift and may ultimately have driven our ancestors to evolve from tree dwellers into upright walkers. Africa, a vast continent full of exotic and bizarre creatures. But one region boasts a richer diversity of life than anywhere else, the Albertine Rift. Here, mutation and evolution have gone wild, creating species found nowhere else on Earth. The Albertine Rift is the southern end of a massive scar that runs through Africa, one of the world's great geological wonders. Just 1% of Africa, this wildlife hotspot has more species of mammal, bird, reptile, and fish than anywhere else in the continent. Geological fury has torn and twisted the Earth into a stunning variety of landscapes. Ice-capped mountains, dry savanna, dense jungles, and toxic swamps. Each environment forces life to mutate and adapt to its unique challenges, or perish. To the west of the Albertine Rift lie vast jungles crawling with life. This is a primate's paradise. In the area around the Albertine Rift, there are more species of monkey and ape than anywhere else on Earth. They have mutated and evolved to take advantage of the natural supermarket provided by hundreds of species of trees. The branches are their highways. It's safer to stay 40 meters off the ground than go down to the forest floor where predators lurk. But one species of monkey takes traveling through the trees to extreme lengths. The red colobus, unique to East Africa. They have learned to use branches as springboards, bouncing up and down on them to launch them further between trees. Using this trick, red colobus can jump gaps in the canopy over 16 times their own body length, the equivalent of a man leaping a whole basketball court. Young red colobus must soon learn to make these death-defying leaps if they want to keep up with the troop. It can take a little while to master the art. Red colobus need to be acrobats because there is another primate living in these trees. one that can turn from a peaceful vegetarian into a savage killer. Chimpanzees' favorite food is fruit, and they can feed on 300 different species of plant in a year. But these apes have a dark side. Sometimes fruit is not enough, and chimps get a taste for meat. And red colobus are their favorite prey. A brave few stay to fight to protect the females and babies. They stand no chance against the intelligent and well-drilled apes. With chilling ferocity, the chimpanzees tear the monkey carcass apart. Fights and arguments break out. The dominant males take the choicest cuts. In this primal world of life and death, there is one outstanding evolutionary survivor. A deadly clan that has prowled the undergrowth since the time of the dinosaurs. Known in Africa as Siafu, they are a fearsome predator. They are African driver ants. Siafu are ruthless killers. They devour almost anything they find. Each ant is tiny, but together they form a single super predator. There can be 20 million driver ants in a colony. All of the workers and huge soldiers are daughters of a single queen. This is the largest family on Earth. Siafu are closely related to ants on other continents thousands of kilometers away. But how? Driver ants are evidence that Africa was once part of an ancient supercontinent. Gondwana was home to their ancestors before it fractured into many smaller continents. One of the largest fragments became Africa. As it drifted across the equator, the center of this huge land became covered in dense tropical jungle. The rich environment allowed mutation and evolution to go wild. The rainforest filled with bizarre creatures of all shapes and sizes, and all of them were potential prey. The original ants of Africa hid below ground, but one group, the Siafu, emerged from the depths to prey on the rich life of the forest floor. Here, the driver ants mutated into terrifying hunters. Their legs became longer to run down their unfortunate prey. Their heads and jaws grew larger to tear them to pieces. But there is one primitive feature they retained from their underground ancestors. Siafu have no eyes. The millions of blind ants communicate using only touch and scent. They obey simple traffic rules by following scent trails left by their coworkers. Constantly sharing information and helping each other, ants are the original social network. At certain times of the year, juicy insects known as sausage flies stumble into the path of these deadly predators. The helpless sausage fly seems doomed. But this is not food. It is a male of the same species. Sausage fly is another name for the male siafu, one of the largest ants in the world. This male flew away from his colony soon after he hatched. Once he reaches sexual maturity, he is drawn back to the scent of a column of female ants. He runs across a raiding party and is quickly swarmed. The female workers kidnap him, chew off his wings, and carry him back to their underground nest. The sausage fly will spend the rest of his short life imprisoned as a sperm donor to the queen. Captive sausage flies father millions of larvae that form the next generation of the driver ant colony. Siafu shift their entire nest every few weeks. Security is on high alert when the new brood are moved. Thousands of huge soldiers stand ready to attack any threat. This new generation will require even more food, and so millions of marauders swarm across the jungle floor. But some creatures have evolved to fight back. This slimy slug seems like another helpless victim of the siafu. The ants quickly attack the slug, and it seems done for. But it has a brilliant escape plan. The slug oozes extra sticky slime, which gums up the ant's jaws. Alone, it's outfoxed an army of predators. The slug casually cruises away, leaving the deadly ants glued together in its wake. For millions of years, the siafu terrorized the jungles that covered the heart of Africa. The center of the entire continent was one big, flat rainforest. But massive geological forces were about to change the heart of Africa forever. 30 million years ago, the Earth's tectonic plates beneath Africa began to drift apart. Over millions of years, a great rift in the crust spread from Ethiopia southwards for thousands of kilometers. In the center of Africa, the Great Rift split into two branches about 12 million years ago. The western one is known as the Albertine Rift. The giant fracture in the Earth changed the landscape and climate. It divided the center of Africa in half, one side dry, the other wet, driving evolution in dramatically new directions. In the vast Congo Basin, west of the rift, lies one of our planet's great forests. The Congo rainforest covers over 1.6 million square kilometers, 4 times the size of California. In its depths lives a mysterious mutant first discovered by European explorers only a century ago. A living fossil named the okapi. Okapi are the size of a horse, browse like a deer, and have stripes on their legs like zebra. But their only living relative is an evolutionary puzzle. The vital clues to this family mystery are the lumps on top of the okapi's head. They're not horns. They're fur-covered growths of cartilage called ossicones. There is only one other animal in the world with lumps on its head like this. Like the okapi, the giraffe has ossicums, and they are even larger. Female giraffes have two, while males have an extra one in the middle. How can the okapi and giraffe be so closely related but so different? The answer lies deep in the past. The okapi and giraffe are the only living survivors of an ancient group of mammals. Today, the giraffe is one of Africa's most iconic animals. Yet curiously, its ancestors lived in Europe and Asia. These original prototypes split into many bizarre forms. Some became giants, like the elephant-sized Civatherium. They browsed the open grasslands of Asia, then moved into northern Africa. The many relatives of the Civatherium spread across southern Europe, Asia, and Africa, until the climate began to change radically. As Asia and Europe dried up, they became extinct. Only those much further south, in the heart of Africa, survived. But as the Great Rift tore through their land, these survivors were forced into two very different evolutionary directions. In the dark and dense jungles of the West, the ancient mammals kept their short legs and compact body shape. That's why the okapi is a living fossil. It has stayed unchanged for millions of years and is still a solitary phantom of the deep forest. On the east of the rift, the climate became drier and the jungles gave way to open grasslands. In this parched environment, vegetation was harder to find. Browsers with greater reach had an advantage, and so they evolved into the long-necked giraffe so familiar to us today. The Great African Rift separated these ancient survivors, creating two very different species. Only two of this bizarre family of mammals still walk the earth. But intriguing clues found in northern Africa hint that a third species survived into human times. A strange animal in ancient desert rock art is thought by many to be a species of Civatherium. These giant creatures may have survived the climate change that drove most of their relatives into extinction, but vanished from the earth around 8,000 years ago. The formation of the Albertine Rift turned the flat jungles of Central Africa into a tortured landscape, thrusting up completely new terrains. The most spectacular are the Rwenzori, the tallest mountain range in Africa. These aren't volcanoes. They are a single slab of the Earth's crust pushed up out of the ground by titanic geological forces. As the rift tore through the continent, immense pressure on the edges squeezed up a block of ancient rock 120 kilometers long, the biggest rift mountains on Earth. Ice, wind, and rain have carved the uplifted rock into peaks over 5 kilometers high. The Rwenzori are one of Africa's most unusual and challenging environments. Towering mountains capped with ice and glaciers sitting right on the equator. moisture-filled air slams into the mountains and unloads its cargo of water. Every year, over 2.5 meters of rain falls here. That's why, in local language, Riwenzori means the rainmaker. All this moisture cloaks the mountains in mist. And feeds lush cloud forest around their base. The mossy forest is home to one of the strangest creatures to live in these or any other mountains. The Riwenzori three-horned chameleon, a true evolutionary freak. This dinosaur-like lizard is found only in the foothills of this one mountain range. Only males have mutated to have triple horns, which they use to defend themselves in territorial battles. Above 3,800 meters, the vegetation of the Riwenzoris changes dramatically. This is an alien landscape, dominated by gigantic plants. These strange, otherworldly species grow bigger here than anywhere else in the world. Lobelias, which in other places only grow 50 centimeters high, tower 10 meters into the mist. These alpine giants must cope with extreme temperature ranges. The sun blazes during the day, but as soon as it sets, the temperature plummets below freezing. There are no real yearly seasons in the Riwenzoris. Up here, it is summer every day and winter every night. Few animals can cope with this altitude and extreme temperature range. But one beautiful and tough little bird has learned to survive where most cannot. The scarlet-tufted malachite sunbird is a high-altitude specialist. Males feed on the nectar of giant lobelias, the only animal that pollinates the giant plants. This environment is too windy and harsh for flying insects like bees to survive. Sunbirds need a lot of fuel to sustain this fast pace of life. A third of his day is spent feeding. The sunbird does not just randomly visit flowers. That would waste precious energy. He has a detailed mental map in his head of all the lobelias in his territory and uses it to find flowers that he hasn't visited recently. As the sun sets, the sunbird faces his greatest challenge. The temperature rapidly drops below freezing. Winter is coming, as it does every night up here. To conserve energy, the sunbird does something utterly surprising. He forces his body temperature and metabolic rate to crash, something no other bird in Africa can match. As the mountain air gets colder and colder, the sunbird's metabolic rate slows down by almost 70%. His body temperature plunges by 15 degrees, and he enters a kind of temporary hibernation called torpor. In this remarkable way, he conserves energy and is able to survive the bitter cold of the Riwenzori's night. As the sun creeps above the rugged peaks, the sunbird reactivates his metabolism, and his body temperature quickly returns to normal. He's ready to face another day. Below the towering Ruwenzori Mountains is a very different environment that drives life to its limits. While the edge of the Albertine Rift was pushed up into mountains, the center sank and over time filled with water to form deep lakes. Around the edges of the lakes are murky swamps. Every creature that lives here must be highly specialized to survive. The jacana has evolved mutant feet that spread its weight and let it walk across floating lily pads. Up here, it's easy to see where you're going. But below the surface, it's a dark and different world. The stagnant water is murky and often critically low in oxygen. Conditions are so toxic that some mutants have evolved astonishing adaptations. The African lungfish is a bizarre and primitive creature that has remained unchanged for 350 million years. It breathes through lungs, which allows it to survive on land, at least for a while. The lungfish will never win any beauty contests, but it is a hero in the evolution of life on Earth. Lungfish are the closest living relative to ancient creatures that made the leap from swimming in water to walking on land. Its long, tentacle-like fins look nothing like legs, but the African lungfish uses them to walk across the bottom of swamps. He inflates his lungs and floats the front of his body off the bottom, then moves his back fins in alternating steps to propel himself along. It's not exactly walking, but it is the first baby step in an evolutionary path that led to creatures of the water invading the land. It may be an evolutionary pioneer, but lungfish get no respect from a feathered monster that makes these swamps its home. The shoebill, a prehistoric-looking bird unique to East Africa. The shoebill prefers to hunt in these low-oxygen waters because it knows the one weakness of its favorite food. Lungfish must eventually come up for air. A vicious hook on the end of their enormous bill has evolved especially to seize hold of slippery fish. The lungfish are nutritious, but slimy. After it swallows one, the shoebill always takes a mouthful of water to wash out the taste. This bizarre and rare swamp predator has no close relatives. It looks like a mixture of a stork, a pelican, and a heron. But it's an evolutionary oddity. There is nothing like the shoebill anywhere else on Earth. The lungfish isn't the only fish in these toxic waters to evolve extreme survival strategies. Professor Lauren Chapman studies another unique group of swamp dwellers.
The mormyrid fishes are a large and species-rich group of fishes that are found only in Africa, nowhere else in the world.
For a long time, these fish were a mystery to science. How do they orientate themselves and find each other in swamps so dark and impenetrable? Scientists only recently discovered the answer. To survive here, mormyrids have evolved an extraordinary ability. They use pulses of electricity to hunt and communicate.
And then we'll see if we can get a good signal.
Lauren
here.
and her research team use a clever technique to detect and measure this electric supersense.
One thing that's really interesting is that we can translate the pulses into sounds. And to do that, we put paired electrodes under the water. And the electric pulses that the fish emits are translated into a sound that we can hear.
A special organ at the base of their tail sends out an electric field that surrounds the fish. When other creatures enter this force field, they distort its shape. The mormyrid can detect these changes using sensitive electroreceptors all over its body. This electrosense is so fine-tuned that it can tell the difference between predators, prey, or fish of the same species. The underwater microphone reveals the hidden world of the mormyrids. They may seem calm, but there is a constant battle of electric signals going on. Every species has a unique electric signature, which it uses to battle for territory, signal its social status, and even impress prospective mates. This extraordinary mutation has enabled mormyrid fish to thrive in the extreme swamp environments of the rift. Africa's Albertine Rift forced the hand of evolution and created unique species of animals found nowhere else. Some of them are our closest genetic relatives. Chimpanzees share over 99% of our DNA, and like humans, are noisy, curious, intelligent, and above all, social. They live in groups dominated by an alpha male and his gang of lieutenants. Each chimp group jealously defends its territory. Males form alliances and security patrols that will attack and kill any intruders they find. When the alpha male and his lieutenants hear a stranger on their turf, they scramble into action. The intruder quickly retreats. He is lucky to escape with his life. Not far away, another highly intelligent ape also makes its home in the jungles of Central Africa. At first glance, they look like chimpanzees, but they are a completely different species. These are bonobos, a mysterious and shy dweller of the deep jungle. Bonobos are similar to chimps in many ways. They both climb the canopy in search of fruit and live in tight social groups with strong family bonds. But there is one remarkable difference. Unlike the violent chimpanzees, bonobos are peaceful and caring. In fact, they are often described as the hippies of the primate world. These two species of ape live in the same jungle environment. How did they evolve such different behavior? The key to this mystery is raging water. Local tribes call it the river that swallows all rivers, but to us, it is known simply as the Congo. The mighty Congo River is 4,700 kilometers long and up to 13 kilometers wide. Before it formed, there was only one kind of chimpanzee in these jungles. But the awesome forces of the Albertine Rift yet again drove evolution in strange directions. For millions of years, the Congo Basin contained a huge lake fed by a river. As the Albertine Rift began to push up mountains and highlands on the eastern edge of the basin, the river slowly bent around into a horseshoe shape. Eventually, it reached the Atlantic Ocean and drained away the lake, leaving behind one of the world's great waterways. This impassable barrier split one ape species in two. Chimpanzees are spread across 22 African countries, all on the north side of the Congo River. Arguments in chimp groups are solved by aggressive threats and violence. Male chimps battle each other for food, mates, and social status. On the other side of the river, females rule a totally different society. Bonobos are only found in one small area south of the Congo River, in the forests of the Democratic Republic of Congo. Biologists only realized bonobos were a unique species in 1929, making them the last great ape to be discovered by science. Dr. Gottfried Hohmann of the Max Planck Society works with the Congolese Wildlife Authority to study these elusive apes.
Bonobos are wild animals, and first they avoid the presence of human beings. They run away, they hide. But if you're persistent, after a couple of months, you are able to follow them at a certain distance, and after 1 or 2 years, you can walk with them through the forest.
Bonobos are physically very similar to chimpanzees, but there is one profound difference between the two apes.
Bonobos and chimpanzees are closely related. They share a long history of evolution, and still they're surprisingly different. And this difference is particularly obvious in the social domain.
There is no alpha male in this troop of bonobos. The real power lies with a group of senior females. Violence is rare in the bonobos' world. Instead, they use intimate contact and food sharing to avoid conflict and diffuse tension in the group. The formation of the Congo River split one species into two. But why did the apes end up so different? Why is there war on the North Bank and peace on the South? One theory suggests that a third species of great ape could have been the cause. Ancestral gorillas had to share the same food resources with chimpanzee ancestors. Today, gorillas only exist in small pockets in Central Africa, but they were once far more widely spread. Some primatologists think that 5 million years ago, gorillas competed with the smaller jungle apes for food. It appears that as the Congo River was forming, the climate of Central Africa changed dramatically. A drought wiped out the favorite food plants of gorillas, and the giant apes disappeared from most of the Congo Basin. When the drought ended, the forests and food plants returned, but the newly formed Congo River prevented gorillas from recolonizing the South Bank. Here, smaller apes had the forest to themselves. They may have fed on a much wider range of plants all year round, without competition from gorillas or each other. They became less violent and eventually evolved into a distinct species we call bonobos. On the north side of the river, the original chimpanzees still had to share their forests with gorillas and compete with them for food. They also had to compete with each other, and this led to a culture of rivalry and violence, dominated by the most aggressive males. It may even have changed their DNA. Scientists have recently discovered part of a gene that seems to promote social bonding. Caring, sharing bonobos have it, and so do humans. But the violent chimps do not. The radical differences between aggressive chimps and peaceful bonobo may ultimately be because of a genetic mutation. The Albertine Rift reshaped the mighty Congo River and split our closest relatives into two very different species. But it may also have forced our ancestors out of the trees and onto two legs and led to the dawn of mankind. Chimpanzees and humans share over 99% of their DNA, but chimps evolved to spend most of their time high in the trees. Immense upper body strength enables them to haul themselves up with muscles 4 times more powerful than a human's. Chimps often come down from the canopy to move between food sources and patrol their territory. When they're on the ground, chimps still use all 4 limbs. They lean on their arms to prop them up as they move across the ground. This is called knuckle walking. Chimpanzees can walk like humans for short distances, but their weak back legs can't take the strain for long. Scientists always thought that our earliest direct ancestors, called hominids, were tree dwellers that looked like chimpanzees. When Africa's climate dried up and the forest disappeared, it was presumed these ancient hominids were forced down to the ground. On the open savanna, they evolved from traveling on 4 limbs to walking on 2. This theory, known as the savanna hypothesis, has been suggested ever since Charles Darwin's time. But a stunning fossil discovery changed that idea forever. In 1994, a remarkable specimen was found on the floor of the Great Rift in Ethiopia. A female hominid who weighed about 50 kilograms and stood 120 centimeters tall. This was the oldest and most complete hominid ever found, 4.4 million years old. This new fossil, named Ardipithecus ramidus, or Ardi for short, shattered our understanding of human evolution. Ardi's limbs and anatomy were different to both humans and chimps. She was still a creature of the forest canopy, with opposable digits on her hands and feet like chimps. the structure of her skeleton showed that Artie could also comfortably walk on two legs, like us. This suggests the ability to walk upright evolved before our ancestors came out of the trees. If this is the case, then the savanna hypothesis is wrong. There might be another reason our earliest hominid ancestors evolved to walk on two legs. The appearance of the earliest bipeds overlaps with the Great Rift tearing through East Africa 3.5 million years ago. An intriguing new theory proposes the driving force behind our ancestors learning to walk on two legs was the formation of the Great Rift itself. Could it be they came down from the trees and entered the hills? This theory suggests that as flat terrain was pushed up into mountains and blasted into craters, our ancestors would have benefited from moving into the new landscapes. Steep terrain would have offered protection from four-legged predators that could not climb and created whole new environments and food resources. As the hominids conquered this new landscape, they could have evolved powerful legs and shorter arms to help them balance and grip. And so they became upright, like us. And as the rift altered the climate of East Africa, perhaps the brains of our ancestors grew larger and more complex to cope with the challenges of surviving in such a changeable environment. The titanic forces at work under the surface of Africa made our species what we are, the ultimate primate survivor. As the Albertine Rift tore through the center of Africa, it transformed flat rainforest into landscapes of staggering variety, each with their own challenges for life. This forced the hand of evolution, creating mutants and unique life forms found nowhere else on our planet.